Hey, good morning, everyone. So what I want to do is expand our understanding of what solutions are. So not just with equations, but also tying them to graphs. So to open, looking at this problem, I want to know what values for x and y can make this equation true. Well, x and y are different variables, and so that's going to mean that they can have two different values. So basically, in other words, what we're doing is we're saying, here's this equation, y equals 3x plus 5. The question is, what can go in for y? What can go in for x to make these two things true? So if I'll zoom in here, make it easier to see. So I'm just going to kind of create a table here of x and y values that end up working. So I'm going to come up with the easiest value for x that I know, 0. Because 0 tends to be a really nice property because when it multiplies with something, we get 0. So if I were to throw in 0 here, well, 3 times 0 would be 0, plus 5 would be 5, and so the y value that would make this true would be 5. So that's one possible combination of x and y that make this true. All right, so let's clean that out. And now let's think of another one. So another combo, let's say maybe I come up with, what if y is 11? So I'm going to work opposite now. So if I throw in 11 for y now, the question is, what would the x value have to be so that we get 11? Well, plus 5, what number plus 5 is 11? 6. And is there a number 3 times that gets me 6? Yep, 3 times 2. So that would be 6 plus 5 is 11, and so that would make this true. And so another combo would be here. And I'll give us one more just to solidify the idea. This time I'll play with some negatives. So what if x was negative 4? Well, if I throw negative 4 in here, 3 times negative 4 would be negative 12, plus 5 would be negative 7. And so the combination that would work here for x and y would be negative 4, negative 7. All right, cool. So that is kind of the most basic case, and some of you might already know what that's going to look like graphically. Now, let's expand these properties just a little bit and say, well, what if y equals x squared plus 1? So remember that x squared has a very specific property. So if I think about this, the question is still the same. It's what could y be? It's supposed to be an arrow. So that some number squared plus 1 is equal to it. So let's say x is 3. The important thing to remember is what an exponent of 2 means. So 3 to the second power, remember, actually means 3 times 3. So it's whatever number is in that box there times itself. So 3 times 3 is 9, plus 1 is 10, and so y would have to be 10 in this case. So 310 would be one of my combos. All right, the second thing, let's see, oh, there we go. Come on, refocus. All right, there's another property we got to be careful of though. Let's say x was negative, say negative 4. Well, if x is negative 4, the key is, remember, it's whatever that number is times itself. And even more importantly, a negative times a negative, remember, is a positive. So negative 4 times negative 4 would be positive 16, plus 1 would be 17. So it's really important to remember that property of negatives with an exponent of 2. All right. And finally, the last case you're going to probably see today, actually I know you're going to see, is if I do something kind of crazy, like I square both values. All right, so not as scary as it looks. So once again, the same rules apply in this case. I'm just saying some number times itself plus a different number times itself equals 100. This one's a much harder question, though, because I'm betting you're going to see that there's a very limited number of options I have for this one. So once again, I'm going to start with 0 because I know it often helps me find the simplest case. So if x is 0, that means 0 times 0, which is 0, plus some number times itself equals 100. Well, it turns out in this case, if I do a 10, 10 times 10 is 100, and so this is actually going to work out. What's cool about this problem is, if I get rid of these, notice how x and y are both being squared. And so I could pretty much do the exact same problem, though I'll do a negative version this time, but backwards. Because this would be negative 10 times negative 10, which would be 100, plus 0 times 0, which would be 0, which would be 100. And so notice how by flipping around the values, I'm able to find another possibility. And I'm going to show you one more in this case. Turns out if I did 6 and 8, that would actually also work. Because 6 times 6 is 36, 8 times 8 is 64, and 36 plus 64 is also 100. And so 6, 8 would be a combo. All right, so that's kind of the big idea. Notice how early, pretty much, I could use whatever I wanted for x and get a y value. B was a little bit harder because all of a sudden this exponent started restricting what numbers I can produce. And then C requires a lot of experimentation to come up with some combos that actually work. All right. All of this is to kind of set you up for today's assignment. So if we take a look, once again, I'm going to give you an equation. So just like example A that we just talked about, problem 1 is just saying if you have this equation, y equals 2x plus 3, I want you to come up with some possible xy pairs that make it work. So if you notice, here's a table similar to what I was doing earlier, and I've given you a combo that works. The question is, if I give you this x value, what would the y value have to be? Or if I gave you this y value, what would the x value have to be? And then there's 2 spaces for you to come up with your own. Notice how -2, -1 has been graphed already. So if you look at the graph, you're going to see that. Now, if x is 0, y equals 2 times 0 would be 0 plus 3 would be 3. And so I'm betting right here the y value would be 3. And notice how it automatically throws the next point on your graph. So as you find combos that make this true, you're going to see some sort of shape, I suppose, being produced. And so when you look at problem 2, it's just going to be saying, as those pairs are graphed, what shape is being formed? And you're just taking your best guess. You'll get some confirmation later. So hopefully that sets you up well. And once again, all the questions you're going to look at here are exactly the same as what we were looking at right here. So take your equation, think about blanks, table of values that make them work. And so you're doing the exact same thing. The only clarification says for part 4, it'll be based on problems from the board. Obviously, you can't do that. You're not in person, so you can skip part 4, but you do need to do parts 1, 2, and 3. We'll talk about part 4 in class tomorrow. As always, let me know if you have any questions, and I'm happy to help you.